See that what they are saying, an RLC circuit, series RLC circuit. Quickly draw the series RLC circuit. R, L and C. That's it. This is what RLC circuit, or JXL minus JXC. So next they are talking about the resonance frequency. See here. Once you see the term in the circuit as resonance, quickly what you do is that if you don't know anything, you no need to remember anything. Once you see the resonance, just do one thing, find the impedance of the given circuit, R plus J, XL minus XC is the impedance. We know that at resonance, imaginary part of the impedance should be 0. This condition you should apply, that's all. What is imaginary part here is
XL minus
XL
XC.
minus XC is equal to 0. Then just you take one step ahead, that this is omega L, this is 1 by omega C is equal to 0. Then omega is equal to 1 by square root LC. That's all. This is what the resonance frequency. This is angular frequency, but if you want directly frequency, you can write F is equal to 1 by 2 pi square root LC. These are what? Angular frequency, radians per second, and this is frequency in hertz. Okay, whichever you need, you can utilize that. Now it is a simple thing that this resonance frequency F is equal to, or Fr is equal to 1 by 2 pi square root of L. How much is the L? L is given as 150 milli into 10 power minus 3. C, how much is the C? C is 60 micro. So 60 into 10 power minus 6. So how much we will get this? Cross verify. So we will get this as 150 into 10 power minus 3, 60 into 10 power minus 6, 1 by 2 pi. So I'll be getting this as 53.08 Hertz. This is what the resonance frequency. Now what else they asked is that, see this corresponding input current. What does it mean? Input current means current taken by this. Under this condition, when it is at 30 volts, that means voltage across this is what? 30 volts. That's all. Just you put every information into circuit form so that it gives a better clarity. Now how much is current? Voltage divided by impedance. How much is impedance under this condition? See that under this condition imaginary part is 0, that means how much is the impedance? So let me write now. At resonance, Z is equal to R plus this imaginary part, but imaginary part is 0, right, at resonance condition. So J0, R plus J0 is equal to simply R. Under resonance condition, imaginary part of the impedance is 0. That is very clear for us. If imaginary part is 0, how much is impedance? Only resistance. Now, how much is the current? Current can be calculated as V by Z. V is equal to simply 30 at an angle 0. If angle is not given, that is treated as reference. Divided by resistance. How much is the resistance? 30 at an angle 0 divided by resistance is 0.3. So how much we will get? 100 amperes. 100 at an angle 0 or simply 100 amperes. So therefore current is equal to 100 amperes. So in this way we can calculate the current. For example, if somebody asks how much is the power? Power taken by this circuit under this condition. So power is equal to simply I square into R. At resonance, at resonance, power is equal to I square into R. How much is the I? 100 square into R 0.3. How much you will get this? Cross verify. Some value you will get.
3,000.
How much?
3,000.
3000. Very good. 3000 watts. So like this you can apply many things. Okay. So this is what the, if you want you can calculate some more things also as like this. Just let me give you. VR magnitude. How much is VR magnitude? Current magnitude into R. If you refer back series RLC circuit, you can check what is VR and how much is its magnitude is I into R. Similarly, VL magnitude. How much is VL magnitude? I into XL. If you want VC magnitude, how much is VC magnitude? I into XC. Just refer back previous class. You will get all these equations, magnitudes of VR, VL, VC. Now tell me how much is I into R? I is 100,
30, sir.
R is 0.3. This is equal to 30 volts. Could you observe that VR and total voltage V are same? See here, total voltage is 30 and resistor voltage is also 30. What does it mean? It means that voltage across this entire combination is 0 volts. Across the inductor and capacitor is 0 volts. So 30 plus 0 is 30. But it doesn't mean that voltage across inductor is 0 and voltage across capacitor is 0. There may be some voltage. Let us see how much is that voltage. Okay. So let us see carefully. How much is VL? I into XL. How much is XL? Let me calculate one step here. So somewhere here beside this, XL is omega omega L. How much is omega? Omega we can calculate. Tell me. So if you multiply this 53.08 with 2 pi, you will get omega, or 1 by square root LC. You can write even in this way also. Omega is 1 by square root LC into L. So L can be written as square root of L square divided by square root of LC. So this becomes square root of L by C. L by C. How much is square root of L by C? See that L is 150 milli, C is 60 micro. You will get some value. Check it. How much is this value? This is what XL. Omega is 1 by square root LC. See, I substituted this value. Just you can directly get the value, or you can just simplify in this way and tell me how much is that value. So did you got this?
2,500, sir.
2500 ohms. Now under resonance condition we already seen that this XL is equal to XC, right? XL is equal to XC. That implies XL is equal to XC. Once I will get the XL, means XC value also same. How much is that? 2500. Now it is easy to cross verify that. So I into XL is 2500. So how much is this? So 250 kV, kilovolt, right? 250 kilovolt. 250 into 10 power 3. In the same way, the current is the same and reactance also same as like inductive reactance. How much is this? This is also 250 kV. Okay, both are same. but how does it become 0? Can you tell me? How does it become 0? One is, if this is the current, if this is the current I in the circuit, one is upward. Which one is upward? Inductor voltage is upward. And capacitor voltage is equally downward, as like this. Because of its nature, angle of the inductor voltage is plus 90, angle of the capacitor voltage is minus 90. Thereby, so you can see that this is plus 90, this is minus 90. As a result of this, this is 2500 or 250 kV upward, this is 250 kV downward. So net voltage is what? 0 voltage. So how does it look like? It look like this. Simply a current, and total voltage is the addition of these two becomes 0, either here or here. So that is very important. So that, see here, this is 250 kV, this is also 250 kV, but in opposite direction. As a result of this, if we add these two voltages, I will get 0. So 0 plus 30 is what? The total voltage. Clear? So these are the extra information about this series resonance concept. Clear? Okay.
Yes, sir.
Thank you.